and share the board. Right here, I'm gonna just log in. Okay, so all right. So as I said, there's one exercise left from section 2.3. So let me just remind you. So section 2.3. So it was about differentiation formulas, right? So we had a couple of formulas, like the product rule, quotient rule, etc. So differentiation formulas. So yeah, so let me remind you, we had so the last rule we had is the quotient rule. So let me just remind you of the quotient rule. So we have two functions, f of x and g of x. Okay, f of x and g of x. Right, two differentiable functions. Right, differentiable functions. Right. And then, so we said if you take f over g, okay, so if you have, let's say you have h of x equal to f of x over g of x. Okay. Of course, here your g of x, you need to exclude the values of x where g of x is 0. Right. So here g of x, let's say it's not 0. Okay. And so we said the derivative, then h prime of x. So this is what we call actually the quotient rule. So then h prime of x is equal to f prime of x times g of x minus f of x times g prime of x, right? G prime of x over g square of x, right? So that's what we call the quotient rule. So this is our quotient rule. Okay. So so I think we had a couple of examples, and we started an exercise. We had an exercise, and I think we had so I think we had the following problem. So we have this. So we have to use the quotient rule to find the h prime of x, right? So we said we have to use the quotient rule to find h prime of x, right? So we had three different functions. I think I solved the first one, right? Now we have there are two functions left. So number 2.
Wait, excuse me, Professor.
Yes.
Can you go back up and move more?
Yeah, sure. Mm-hmm.
And move more to the left.
To the left. Yeah. All right. To the left.
Okay.
Mm-hmm. Okay. Yeah, so we had, I think, the following function. So we had, I think, h of x equal to x squared minus x plus 1 over square root of x minus 1, right? And The third one, so we solved number one. This is the second. The third one is, if I'm not mistaken, so number three, h of x. H of x was, I think, 2 plus x over third root of x. Third root of x plus 1, right? Yeah. So we had so we have to compute h prime of x, right? So we want to use the quotient rule to find h prime of x, right? So so for number two, guys, I'm not sure if you had time to finish or to try number two. But anyway, so let's just probably finish, solve these two functions here, derivatives. So for number two, so your h of x is x squared minus x plus 1 over square root of x minus 1. So the function in the top, that will be my f of x. So this is my f of x over the g of x. All right. So so we need, so we said we have to use the quotient rule to compute the derivative, h prime. So then we said h prime, so h prime would be h prime of x. So the quotient rule says that h prime would be f prime times g, right, minus f times g prime over g squared of x, right? So so to use this quotient rule, we need first, well, we need to find f prime, right? And we need to find g prime, okay? And, okay. So what would be f prime, guys? Any guess for f prime of x? So f of x is the x squared. So f of x is the x squared minus x plus 1, right? So what would be f prime of x?
2x minus 1.
2x minus 1? Yep,
Yes.
absolutely, yeah. Yeah, correct. So it's 2x minus 1, right? Because, so let me just remind you the power rule. So if you have x to the power n, right, and you want to compute the derivative, so what you do is you bring down the power, the n, right, the power n here in front of x. So we're going to have n, x, and then you subtract 1 from the power, right? So, and then you subtract 1 from the power, so that will be x to the n minus 1. Right? So for example, for x squared, so we start with x squared. So we have x squared minus x plus 1. So we have subtraction and addition, right? So we said, you know, we can compute first the derivative of x squared. This is my square here. You bring down the power. So that will be the 2 here, right? And then you subtract 1 from 2. So 2 minus 1, subtract 1 from 2. So 2 minus 1 would be 1, right? So that's the 2 times x power 1, which is 2x, right? And then we have minus here, right? And then x, that's x power 1, right? X is x power 1. So we have to bring down this power in front of x and then subtract 1 from the power, right? So you bring down the power, the 1 here, and then x to the power 0. Remember, guys, we said any non-zero number power 0 is 1, so x power 0 is 1, right? So that's why we have minus 1 times 1, which is minus 1. And then there's a plus. So here's a plus. But here we have a constant, right? Just 1 by itself, right? So you have a constant by itself, then the derivative, we said, derivative of a constant is 0. So here it should be plus 0, right? So yes, Yeah, so the correct answer would be, so f prime of x would be 2x minus 1, right? So f prime of x is 2x minus 1, right? Now, what about g prime of x? So we need to use the quotient rule, we need the g prime of x, right? So my g of x is square root of x minus 1, right? So any guess for g prime of x? Remember, guys, this is square root of x. We can write square root of x as x to the power 1/2, right? That's x to the power 1/2, right? So that's x to the power 1/2 minus 1.
So 1/2 times x to the power minus 1/2.
Yeah, to the power negative half. Yes, so absolutely. So if you want to compute the derivative, so here first you start with the square root of x, the x to the power half. You bring down this power here in front of x, so that will be the half. So we're gonna have half times x, and then of course you subtract 1, all right? So then x, that will be x to the power 1/2 minus 1, right? 1/2 minus 1. And then here we have minus, and then derivative of a constant, as we said, it's just 0, right? So then g prime of x would be, so g prime of x would be half times x to the power half minus 1. Don't forget to get a common denominator, right? Here it's minus 1 over 1. Yeah, so that's,
Got one
so
eye on
then,
you and one eye on this.
so that's x, so that's x to the power negative half, right? Okay, so that's our g prime of x. And then now I can apply my formula, so I can come back, I can come back to h prime of x. So h prime of x, we said, so h prime of x, so it's gonna be f prime times g, right, minus f times g prime over g squared, right? So my h prime of x, so f prime, we said f prime is this, 2x minus 1. Don't forget to use parentheses, guys. So it's parentheses 2x minus 1. That's my f prime. Next, times g, right? The g is this square root of x minus 1. So times square root of x minus 1, right? Now, so there is a minus. See, there's a minus here. This minus, so I'm going to subtract, right? And then we have f, right? So where's my f? Well, f is the x squared. Here's my f. The x squared minus x plus 1, right? So minus x squared minus x plus 1, right? That's my f. And then times
Professor, we can't hear
yeah.
you.
You cannot hear me?
I can hear you.
I can hear you too.
I can't hear the professor.
Probably you have a problem with your
I can hear you.
microphone or your computer. Everyone else hears me?
Yes.
Yes, Professor, we hear you fine.
Okay, okay.
Maybe he's having a
I think-
problem. He needs to log out
Yeah.
and log back in.
No, I figured it out. Thank you.
Okay, perfect.
Okay.
Perfect. Thank you. All right. So then, so then times, we said times the g prime. So here's the g prime, right? So where's my g prime? Well, g prime, we said it's this, this half x to the negative half, right? So it's g prime, it's half half x to the power negative half, right? And the whole thing, of course, divided by the g square, right? So my g again is the square root of x minus 1 square. All right. So yeah, then of course you can try to simplify this expression, guys, right? You can try to distribute and see if you can you know, simplify things in the top, right? So so let's see if we can simplify the top, the numerator, right? So we have h prime of x, right? So you distribute. You see here 0, 2x times the square root of x, right? And then 2x times 1. So we're going to have, so 2x times square root of x. So that will be 2x to the power. So remember, guys, this is x is a power 1, right? And square root of x, that's x to the power 1/2, right? So you can, so we have the same base, which is x, right? So we can combine the powers. We can add the powers, right? It's 1 plus 1/2, right? So this is 1 plus 1/2, that will be 3/2, right? So this is x to the power 3/2. Then there's a minus. This is minus here, so minus 2x, right? Now we have to multiply 1, right, by square root of x, and then by 1. So that will be minus, right? You have a minus here. So it's minus 1 times square root of x. And then there's a minus, minus. So there will be a plus 1, right? And then there is, so we have this minus here, right? And then, well, we can multiply, you see here, this is, so this, you know, x squared times this x to the negative half, right? And there's a half here, so that's half. Now, x, we have the same base, right? So again, we can add the powers. So so power 2x squared times x to the negative half. So so that would be x to the power. So 2 minus half, that will be 3/2, right? And then we have a minus, right? So just be careful, distribute the sign, minus, minus, that will be a plus. So it's a plus, all right, plus half. Again, half. Here, this is x power 1. This is x power negative half, the same base. So we can add the powers. So 1 minus half, that will be half. So this is x to the power half, all right? And finally, there is, again, this is a minus plus. So that will be a minus. And 1 times this half x to the negative half. So that's a minus. So that will be minus half. Minus half x to the negative half, right? Okay, and the whole thing, of course, divided by, so I'm going to divide the whole thing by square root of x minus 1 square, right? So let's see if we can simplify. Well, you see, guys, here we have x to the power 3/2, x to the power 3/2, right? So 2x to the power 3/2 minus half of x to the power 3/2. So 2 minus half, that will be 3/2. So that's, so then your h prime of x, right? So then your h prime of x, right? So that will be 2 minus half, we said that's 3/2, x to the power 3/2, right? What else? Well, here we have this square root of x, right? There is this square root of x here, and here we have half of x to the power half, right? X to the power half, that's square root of x, right? So minus square root of x plus half of square root of x, right? So minus 1 plus half, that will be minus half, right? So it's minus half square root of x, right? What else? I guess that's it, right? Because then we have this minus, you see here, there's this minus 2x. So I'm going to subtract minus 2x. There is a plus 1. So here's my plus 1. And then there's this minus half x to the negative half, right? And the whole thing divided by this square root of x minus 1 squared. Anyway, guys, I mean, it's up to you. You can, you know, of course, you should try to simplify your answer. But anyway, so that's our h prime of x, right? Is there any question, guys? So
Yeah, I have a question.
yeah.
I don't
Go ahead.
completely understand how you did this. I understand a little bit. Like, why are you putting half as a
Here,
why are you
right
putting
here,
1/2?
here.
Yeah, there, and why are you putting it as an equation? Is it the
Well, that's
equation?
because that's because of the you know, our g prime. You see here. Oh, sorry. So you see here, this is our g prime, right? So that's our g prime. So when you in the quotient rule, we have, you know, we have f times this g prime. So here you see this is my f, right? And we have this, you know, we have this half of times x to the negative half. That's our g prime.
Okay.
So that's why I have this half. That's from the g prime. And then, you know, we have to multiply. If you, when I multiplied, right, I have to multiply this thing here, you know, by the x squared, and then by this x, and then by 1, right? So that's why I got all these 1/2 here.
Okay, I'll look at the notes from the other day again.
Okay. No, but it's just, you know, well, I try to simplify it to see if there's any simplification here. So that's why I try to distribute, and yeah. So that's why I got this half. It's from the g prime. It's just from this g prime. And then, of course, when you multiply, when you distribute, you have to multiply each time by the half, right? So that's why I got all these halves here. This one here, this one here, and this one here. But anyway, so it's, yeah, it's just from the g prime.
Okay, thank you.
All right. Yeah, sure. Anyway, so that's for number 2. We had so number 3, function h was, so number 3 we had h of x. So h of x was 2 plus x, right? Square root, third root of x plus 1, right? So so again, this is the same idea. It's a fraction. So if it's a fraction, so it's we have to apply the quotient rule. Again, the top, that will be our f. So that will be the 2 plus x, that will be our f, and the denominator, that will be our g, right? And so again, we have to apply the quotient rule, right? So so we need to apply the quotient rule. So we need to compute actually h prime of x, and we
Professor,
said,
I have a question.
yes,
So
please.
I notice every time we do this, you square the denominator. Can you explain why?
That's because of the formula of the quotient rule. So you see here, again, the quotient rule. You see the denominator here.
G square.
There is a square. Yeah, it's always a square. Yeah.
Okay.
And yeah, and be careful. It's a minus here in the top, right? It's a minus. It's a subtraction. It's not a plus. Okay, so there are two things you have to be careful with. There's a minus here. It's not a plus, and there's a square in the denominator. Yes.
Okay, thank you. I see.
Yeah, sure. Yeah, so let's come back to this number 3. So we had, our h prime of x. So as I said, yeah, the quotient rule, yeah, it's f prime g minus f g prime over the g square, right? So we need to square the g, right? So anyway, yeah, so we need the f prime, we need g prime first, and then we can compute our h prime. So what's f prime? Well, f of x is, we said it's 2 plus x, right? So then our f prime, well, first we have just a constant, just a number by itself. So then, and we said derivative of a constant, a number by itself is just 0. So here we're gonna have 0. Then there's a plus, and then there's x. And again, guys, x, it's x to the power, it's x to the power 1, right? So we can apply our power rule, right? So you have to, bring down this power here in front of x, and you subtract 1. And if you do that, you get 1, right? So that's, so derivative of x, that will be 1 times x to the power 0. But again, x to the power 0 is just 1. Okay, so it's 1 times 1. So yeah, so our f prime of x is just 0 plus 1, which is equal to 1, right? And so that's for f prime. Now, what about g prime? So g of x, we said it's third root of x plus 1, right? So how do we compute? What will be g prime? Any guess, guys, for g prime?
1/3
Yes.
x and 1/3 minus 1/1.
Yes. Yeah. Very good. So you are saying first, so this third root of x, we can write like x to the power 1/3 plus 1, right? And you are saying we have to bring down this power here. So that's 1/3, right? And then x, and then you have to subtract 1, right, from the power. So that's the 1/3. As you said, it's 1/3 minus 1. And then there's a plus here. So here's my plus. And then again, this is a constant, and derivative of constant, of course, just a number by itself is just 0. Yeah, so now 1/3 minus 1, of course, don't forget, guys, you need the common denominator. So it's this one here should be, yeah, so it's 1/1, common denominator, you multiply by 3, right? So that's 1 minus 3, that would be -2. So g prime of x would be 1/3 x to the, so 1 minus 3, that would be -2. And the common denominator is 3, right? So it's -2/3 plus the 0. Okay, so my g prime of x is just 1/3 of x to the power -2/3, right? Now, so I got my f prime. I have my g prime. Now I can apply my quotient rule, right? My h prime. So let's see. Let's see what we get. So h prime of x. So first we have f prime. So f prime is, we said f prime is just 1, right? So it's 1. That's my f prime times g. Here's my g. My g is third root of x plus 1. So third root of x, or x to the power 1/3 plus 1, right? And then there's a minus. There's a minus here. So here's a minus. And then f, right, is f. So my f is the 2 plus x. Don't forget to use the parentheses. So we have parentheses, my f, that's 2 plus x, and then times the g prime. So g prime, here's our G prime, is the 1/3. So here it's multiplication, right? Times the 1/3 x to the power negative 2/3, right? That's negative 2/3 here, right? And the whole thing, of course, divided by the G square. So the G, it's the third root of x, or x to the power 1/3 plus 1 square, because of the quotient rule. All right. Yeah, so let's see if we can simplify the numerator, right? Let's see if we can simplify the top. So it's, you know, it's, so h prime of x. So 1 times the x to the power 1/3, or third root of x, it's just x to the power 1/3. And then there's a plus, right? So here's my plus. 1 times 1, it's 1, of course, right? And then we have minus. We multiply the 2 here by this whole thing, right? So it's 2 times the 1/3 times the x to the power negative 2/3, right? So it's 2 times 1/3 times the x to the power negative 2/3, right? And then there's a, if you distribute the sign here, guys, minus a plus, that will be a minus. So here's a minus. And now, now we have x times, right? This is this x here times this thing here, 1/3 x to the negative 2/3, right? So we're gonna have the 1/3 minus 1/3. Now, what about x times the x to the negative 2/3? So that would be x, the same base, and we add the powers, right? It's x is power 1, right? So it's 1 plus the negative 2/3. So it's 1 minus 2/3, right? And so then denominator, of course, is the same thing, plus 1 square. Anyway, so this is 1 minus 2/3. That will be, of course, common denominator. That will be 1/3, right? So we're gonna have h prime of x. So x to the power 1/3 plus 1 minus 2 times 1/3. So that's minus 2/3 of x to the negative 2/3. And then minus 1/3 x to the power. So 1 minus 2/3, as I said, is going to be 1/3, right? Over this, the third root of x plus 1 square. So here, well, we have one simplification here. As you see, guys, there's x to the power 1/3 here and x to the power 1/3 here, right? So we can combine, we can subtract. Here it's 1, right? Minus 1/3. So 1 minus 1/3, that will be common denominator. That will be 2/3, right? So our h prime of x. Our h prime of x. So it's gonna be so 1 minus 1/3, that will be 2/3 times x to the power 1/3. And then here we have plus 1. So here's my plus 1, and then there's this minus 2/3 x to the power negative 2/3, right? And the whole thing divided by this third root of x plus 1 again square. Okay. So, I mean, in general, whenever you have this quotient rule, try to simplify, you know, at least the top, right? So just be careful, you know, with the algebraic manipulations when you multiply, when you distribute the sign, etc. Right? And don't forget the denominator is always it's g square. Any question, guys, about this quotient rule?
Professor, you said when you have a constant, it's 0?
Yes. Like here.
The number 2, yeah.
Yeah, I mean,
Okay.
like here, yeah, 2 here, we said we have a constant, a number by itself. The derivative is a 0. Yes.
Okay.
Mm-hmm. Yeah, absolutely.
Thank you.
Mm-hmm.
Excuse me, Professor, can you go down?
Go down?
Yeah, like that.
Yeah, sure. Mm-hmm. Yeah, sure.
Can you move more to the left a little?
To the left? Okay.
Yes. Okay, thank you.
Mm-hmm.
I'm
Yeah, so yeah, guys, I mean, the main rule we use here, I mean, of course we use the quotient rule, but I mean, we only had powers of x, right? Because we know how to compute the derivative of a power of x to the n, right? Derivative of x to the power n, we said it's n, bring down the power, and then you subtract 1 from the power, right? So nx to the power n minus 1. Anyway, so yeah, so next we're gonna compute the derivative of trig functions, right? After powers of x, we're gonna do now derivative of trig functions, right? So actually that will be the section 2.4. Can I move to the next page?
yes, you can.
Thank you. All right, so yeah, so we are done actually with this section 2.3. I mean, we did the product rule, we did the quotient rule, right? So now, so we can move to the next section, section 2.4. So differentiation of trig functions. Okay, so we're gonna compute the derivative of sine of x, cosine of x, etc. Right? So we're gonna use actually the definition of the derivative to compute the derivative of sine and cosine. So the goal today, so the goal in this section here is first, so to compute the derivative of sine of x, sine of the angle x, and cosine of the angle x, right? So to compute the derivative, guys, of sine and cosine, we're gonna use the definition of derivative, of course, but we're gonna need two limits. So the first limit we're gonna use, we already used this limit before in the chapter 1. So let me just remind you. So in chapter 1, when we compute the limits, we know that limit when x goes to 0 of sine of x over x, right? So whenever we have the same number of x's, right? We said when x goes to 0, that will be equal to 1, right? So we have this. We know this limit, right? So first, before computing the derivative of sine and cosine, I'm gonna prove the following limit. So we're gonna need another limit. So here, fact. If we have cosine, then actually I claim that limit x going to 0 of 1 minus cosine of x over x, all right? This limit here is gonna be equal actually to 0, right? So of course, guys, I'm gonna prove it, but let me just say here, of course, if you replace x, if you substitute x by 0, right? If you substitute x by 0, you know, 1 minus cosine of 0 over 0. Cosine of 0 is 1, right? Cosine of the angle 0 is 1, right? So that'll be 1 minus 1 over 0, which is 0 over 0, right? That's indeterminate form, right? But so I claim that actually this limit 1 minus cosine of x over x when x goes to 0 is going to be equal to 0. All right. So why is that? Well, so we can actually prove it using the sine of x over x equal to 1. So So let me show you why this 1 minus cosine of x over x when x goes to 0 is equal to 0. So here's the proof. Well, we're going to use a trig, actually, to prove this limit, we're going to use a trig identity, okay? So the thing is, you know, if you have 1 minus cosine of x over x, so what we can do is, you know, I know the limit of sine of x over x is equal to 1, right? So I know when you have a sine of x over x, I know that the limit is 1. So here I have cosine. So the goal is to have a sine. And so what we can do is use trig identities. So what we can do is we can multiply here the top, right, and the bottom by 1 plus cosine of x, right? So this is equal to, so again, this is, I'm trying to compute or find another expression for this 1 minus cosine of x over x. So what I'm saying is this thing here is equal to, so I can multiply over x. So I can multiply by 1 plus cosine of x. So it's like a conjugate, right? So so here 1 plus cosine of x over 1 plus cosine of x, right? And so remember, guys, we have, this is a minus b times a plus b, right? Well, a minus b times a plus b, we said it's a squared minus b squared, right? So it's 1 square minus 1 square is 1, of course, minus b square, and minus b square is cosine square of x, right? Over this x times 1 plus cosine of x. And now you can see we're going to have sine because, you know, guys, cosine square plus sine square is 1, right? So here, I'm using the fact that, you know, the trig identity cosine square plus sine square is 1, right? So if you subtract cosine, minus cosine square here, and minus cosine square here, right? Then sine square of x is going to be equal to 1 minus cosine square, right? So all I'm saying is this 1 minus cosine of square of x is going to be equal to sine square of x. So we're going to have sine square of x here, right, over well, the same thing, x times 1 plus cosine of x, right? So why I'm doing this? Because now, if you want to compute, I want to compute limit of 1 minus cosine over x, right? So I want to compute limit, x going to 0, of course, of 1 minus cosine of x over x. So this is actually the same as, so we just proved that the 1 minus cosine of x over x is the same as sine square over x times 1 plus cosine. So this limit is the same as limit x going to 0 of sine square of x over x 1 plus cosine of x. Okay, and here, guys, you can see something which is what we are familiar with, right? Sine of x over x, we know it's 1, right? Remember, sine of x over x, the limit is 1. And here, exactly, you see there is this, we have sine of x over x here. That would be 1, right? So, okay, so let's use this. So let's use it to compute the limit. So we have limit x going to 0. So sine square of x, I can write it like sine of x times sine of x, right? That's my sine square in the top. Now in the bottom, I have x, and I have 1 plus cosine of x, right? This is multiplication here, right? Anyway, so here you see, guys, there's this, so sine of x over x, we know that the limit is equal to 1, right? So if you replace x by 0, so they'll be equal to, so if you replace x by 0, we're going to have 1 times sine of 0 over 1 plus cosine of 0. All right. So, again, I just substitute x by 0, right? I know this, I know this limit here, this one here, sine of x over x, that's equal to 1, right? We said it's equal to 1. So that's why I have 1 here. That's my 1 here. All right. Now, what's left is this thing here. All right. And I substitute x by 0. So sine of 0, and then 1 plus cosine of 0. Now, sine of 0, sine of the angle 0 is 0, right? Over 1 plus cosine of the angle 0 is 1, right? So it's, in the denominator, it's actually 1 plus 1. So this limit is actually equal to, so it's just 0 over 2, which is, of course, 0 over any non-zero number is 0, right? So anyway, guys, what I'm saying is, so this is just the proof that, so if you want to prove that one limit of 1 minus cosine of x over x approaching 0 is actually equal to 0. Okay. And why I'm doing this, because we're going to use it now, we're going to use it to compute the derivative of sine and cosine. So anyway, so all you need to know, guys, is that first, of course, we're going to use our this limit of sine of x over x equal to 1. And now we have also this new limit, 1 minus cosine over x, x going to 0 is actually 0. So we're going to use this to compute the derivative of sine and cosine. Okay, so we're going to use them. So we're going to use the limits, the two limits to compute derivative of sine and cosine, derivative of sine of x and cosine of x, right? And so let me now show you how to compute the derivative of, let's start with sine, okay? So, so derivative of trig functions. Let's start with sine. Okay, so derivative of sine of x. Right? So by definition, remind you guys, what's the definition of the derivative f prime of x? Remember, we said f prime of x in general. So f prime of x by definition, right, is the limit h going to 0, right, f of x plus h minus f of x over h, right? That's the definition of the derivative. Now, my function f is sine of x, right? So I want to compute f prime of x. So I want to compute the derivative of sine. So my f of x is actually sine of x, right? So anyway, so in this derivative, I need to compute this limit, I need f of x plus h. So what would be f of x plus h? F of x is sine of x, right? So f of x plus h, just substitute x by x plus h, right? This x here by x plus h. So we're gonna have sine of, so we substitute x by x plus h, so we're gonna be sine of x plus h, right? So anyway, so yeah, f prime of x. So my derivative, f prime of x, by definition, so it's limit h going to 0 of sine f of, you see here, f of x plus h. So it's sine of x plus h. Then there's a minus. So here's a minus f of x. My f of x is the sine of x, of course, over h. Again, guys, just be careful. You cannot separate the sine from the x plus h, right? I mean, for example, here you cannot, for example, cancel out the h. It's not because you have an h in the top and an h in the bottom, then you can cancel out the h's, right? That's the sine of the angle x plus h, right? They come together. You cannot separate the x plus h from the sine, right? Yeah. So anyway, so I want to compute this limit. So of course, if you just substitute h by 0, if you say my h is 0, so that's how we compute limits, right? You just substitute your h by 0. But if you substitute h by 0, you're going to have sine of x minus sine of x. That will be 0, of course, 0 over 0, right? So it's just indeterminate form. So we need to find another way to compute this limit, of course, right? And so how can we compute this limit? Well, the idea is to, so this is, of course, as I said, this is just 0 over 0, right? So the idea would be to use trig identities, of course. So use trig formulas or trig identities, right? Okay, well, so for example, we have this sine of x plus h, right? We have this sine of x plus h. And actually, we have a formula for sine of a plus b, right? So just to remind you, sine of a plus b. So we're going to use actually the following trig identity. So we have sine of a plus b, right? That will be sine of a times cosine of b, right? And then plus cosine of a sine of b. Oops. Sine of b, right? So this is sine of b, right? And in my limit, guys, I have this sine of x plus h. So I need sine of x plus h, right? So it's like saying my a is x, and my b is h. Right? So sine of x plus h, that will be sine of x cosine of h plus cosine of a, which is x, so cosine of x, sine of b, which is h, sine of h, right? So I'm going to use this this identity here for the sine of x plus h, right? So so my f prime of x, so my f prime of x, f prime of x, so it's going to be limit h going to 0, and then, as I said, I have this you know, sine of x plus h, and so that will be, so we said that will be sine of x cosine of h plus cosine of x sine of h. All right. So again, guys, I'm using this trig identity here. Sine of x plus h is this whole thing here, right? And then we have minus sine of x. So here's minus sine of x, okay, over h. Okay. So what I'm gonna do, guys, so let's see if we can, factor. So for example, let's see if we can factor the top. So for example, here in the top, you can see there is a common factor. Here sine of x, cosine of h, and here sine of x. So sine of x would be a common factor, right? So I can factor out sine of x there. So my f prime of x is limit h going to 0. So as I said, sine of x here is a common factor. So I'm going to factor out sine of x. So here's my sine of x times. And then here, there's this cosine of h. So here's my cosine of h. And so if you pull out the sine of x here, you are left with 1, right? This is supposed to be 1 minus sine of x, right? So it's cosine of h minus 1, right? And then, of course, there's this cosine of x, sine of h, right? And the whole thing divided by h. So I'm gonna split the top, this fraction into a sum, right? So this thing here over h and this thing here over h, right? So do you see, guys, here any limit that we know? For example, you see here there's this sine of h over h. It's like sine of x over x going to 0. So here the same, h is going to 0, and we have sine of h over h. So this thing here, this should be equal to 1, right? Now, what about this cosine of h minus 1 over h? So so we have this formula, right? With the we said, you see here, guys, this is this fact here. We said if you have 1 minus cosine over x, if you have this 1 minus cosine over x going to 0, so the limit would be 0, right? 1 minus cosine of x over x, right? And here we have it's cosine of h minus 1 over h. So it's like cosine of x minus 1 over x going to 0. So this thing here, so this thing here looks like this one here. It's like, it's the opposite of, so it's minus 1 minus, cosine of h over h, and h going to 0, right? So it's like x going to 0, 1 minus cosine of x over x, right? And we said this is equal to 0.
Multiply by minus 1.
Yes, 0, yes, absolutely. 0 times, yeah, thank you. It's negative minus 1 times 0, absolutely. So it's minus 1 times 0, which is 0, right? So this limit here, this cosine of h minus 1 over h going to 0, h going to 0 is equal to 0. So you see, guys, so you see how you use the two limits to compute this derivative. So now my f prime of x would be equal to, so now my f prime of x, so it's gonna be sine of x. Sine of x doesn't depend on h, right? So it's just it's like a constant, right? With respect to the limit. The limit is with respect to h, right? So this is sine of x times 0, my 0 here, plus So I have this sine of x, sorry. So I have this sine of x, this one here. So here's my sine of x. Time is 0. And then we have a plus. And then there's cosine of x, this one here, right? Cosine of x times 1. Right? So f prime of x is actually equal to, well, 0 plus cosine of x is equal to cosine of x. So guys, we just proved, so this is the proof, of course, in the test or in the final, we don't have to prove this again, right? But that's the proof of the derivative, that the derivative of sine is actually cosine. So, so that's our first derivative. So, so our for this, so derivative. So conclusion.
Perfect. Okay.
Yes.
So if we have a limit when x go to 0,
Yes.
cosine of x minus 1 over x, we can deduct automatically equal to 0.
0. Yes.
So we don't
Yeah.
multiply by minus 1.
Yeah. Yeah. You can just say it's 0. Yeah, of course. Yeah. So yeah, absolutely. So we just proved that. So if f of x is sine of x, oops, if f of x is sine of x, then the derivative f prime, then f prime of x is equal to cosine of x. All right. So again, guys, so all you need to know, of course, is that the derivative of sine is cosine. But this is just, this is the proof. This is how we prove that the derivative of sine is cosine, right? Okay, guys. You know what? Probably as an exercise. So I'm going to give you an exercise, and where you have to compute the derivative of cosine. Okay. I'm going to give you the trig identity that you're going to need to compute the limit. All right. So it's an exercise. Exercise. Okay. So let's say f of x is cosine of x now. Right. So prove or compute f prime of x. Compute f prime of x. So you probably don't like the word proof, but so let's compute f prime of x. Okay. So using, well, now for cosine of x, of course, when you use the limit definition of the derivative, you're going to have cosine of x plus h, right? So we're going to need cosine of a plus b, right? So using that, cosine of a plus b is equal to cosine of a times cosine of b, actually, minus sine of a times sine of b. Right. So, please, guys, try to follow the same steps as I did for sine of x. Right. So try to compute. So first thing, of course, is to write down the definition. Right. So let me just remind you the definition. So f prime of x should be limit h going to 0. F of x plus h minus f of x over h. Okay, so this is your starting point, right? You start from here, all right, and then at some point you're gonna use this trig identity, right? So please, I'm gonna give you a couple of minutes to think about this derivative of cosine, right? Try to use the same, follow the same steps, like what I did for sine of x, right? So and of course you're gonna need the two limits. The sine of x over x is equal limit x going to 0 is equal to 1. So and also so we're gonna use, so just to remind you here, so limit x going to 0 of sine of x over x is 1, and limit x going to 0 of 1 minus cosine of x, or cosine of x minus 1. Let's say cosine of x minus 1 over x. This is equal to 0. Right? Equal to 0. So I'm here, guys, to answer your questions if you have any.
The final result is minus sine of x.
Yeah, absolutely, Ibrahim. Yeah, final answer should be minus a sine of x. Yeah, absolutely. Yeah, very good. You got minus sine of x.
Yes.
Yeah, very good, very good. So now you can, for example, so once you compute derivative of cosine, right? You said it's minus sine. You can try, for example, to compute the derivative of tangent, right? Using the quotient rule.
Okay.
Tangent of x.
Okay.
So if you are done with this exercise, guys, you can, so let's say this is exercise number 1, right? So exercise 1, so 2, so you can try to compute, let's say f of x is tangent of x. So tangent, tan of x, it's by definition, it's a sine over cosine, right? You can try to compute f prime of x. Compute f prime of x using the quotient rule. Right, because so we said tan of x by definition is a sine over cosine. And now we know the derivative of sine is cosine, and derivative of cosine is going to be minus sine, right? That's what we're going to prove in the exercise number 1. And then, so once you know the derivative of sine and derivative of cosine, you can compute, for example, derivative of tangent or derivative of cotangent, etc., etc. So anyway, so I'm going to give you a couple of more minutes, and then I will go over the exercises.
Professor,
Mhm.
it's 1 over cos square of x.
Yes, 1 over cosine square of x. Yeah, very good. The derivative of tan, right? That's 1
Yeah.
over cosine of, yeah, 1 over cosine square. That's actually, by definition, secant of x is 1 over cosine. So then actually derivative, so 1 over cosine square, that's secant square.
Say it again.
So what I'm saying is secant of x, it's 1 over, by definition, it's 1 over cosine of x. So you got 1 over cosine square, right?
Yeah.
So if you do secant square, that will be 1 square cosine square, 1 over cosine square, right? So what I'm saying is, yes, your answer is correct. And actually one.
I just use cos square of x plus sine square of x equal to 1. So I just
Yeah,
replace the 1.
Yeah, absolutely, you're correct. Yeah, I'm just saying. If you wanna use a secant of x, for example, then then the 1 over cosine square is just a secant square. But yeah, of course,
Oh,
that's
okay.
correct. Yeah. Okay.
So,
Well.
so it's also equal to secant square.
It's also equal to secant square. Yeah, secant
Okay.
square. Yeah. Okay. Well, so okay. So let me solve the first exercise, exercise 1. So I'm gonna move to the next page. So again, guys, in this section, what we are trying to do is to compute derivative of trig functions. So I have to prove, why we get such formulas, right? Why the derivative of sine is cosine, why derivative of cosine is minus sine, etc. So, but later, in the test or in the final, you don't have to prove anything, right? You can just use the formula, right? So we already proved this in the class, right? So you can just use the formula. You don't have to prove it again, right? So yeah, so the first exercise, we said it's to prove that derivative of cosine is minus sine. So my f of x, we said it's cosine of x, right? And I want to compute f prime of x. So by definition, we said it's limit h going to 0 of f of x plus h minus f of x over h, right? That's the definition of the derivative, right? F prime of x. Now, of course, my f of x is cosine of x. So then my f of x plus h, right? Because in the definition, right, I need f of x plus h, right? This is f of x plus h. So I need to find f of x plus h. So if f of x is cosine of x, f of x plus h, of course, would be just cosine of x plus h, cosine of the angle x plus h, right? So my f prime of x is supposed to be limit h going to 0, cosine of x plus h minus, this minus here, minus f of x, it's cosine of x over h, right? Now, I want to compute this limit, right? always the first step, whenever we want to compute any limit, you can just replace your h or your x by the number given in the limit. So here h goes to 0. So if you replace h by 0, then that will be cosine of x plus 0. So that's cosine of x minus cosine of x, it's 0. And h is 0. So it's 0 over 0, which is indeterminate form, right? That's indeterminate form, 0 over 0. So that's why we have to use the trig identities, right? So the trig identity we're going to use, of course, is this for this cosine of x plus h. So the trig identity says the following. So if you have cosine of a plus b, right? We said cosine of a plus b. So this is, of course, indeterminate. So cosine of a plus b, that will be cosine of a times cosine of b, right? We said minus sine of a and times sine of b, of course. All right, that's my trig identity. Now, we need, cosine of x plus h, right? So we need cosine of x plus h. So my a is going to be x and my b is going to be h. So that's cosine of a, so that's cosine of x, cosine of b, cosine of h, sine of x, sine of b, that's sine of h, right? Okay, so that's my trig identity. Now let's use it, right? F prime of x, limit, h going to 0. So I have this, cosine of x plus h. So I'm going to use my trig. Here, I'm going to use my trig identity. All right, so that's a cosine of x plus h. So it's going to be cosine of x times cosine of h minus sine of x sine of h. All right, that's this cosine of x plus h. And then, of course, there's a minus. So here's my minus. And then minus cosine of x. So minus cosine of x. Oops. So minus cosine of x. The whole thing, of course, divided by h. All right. Now, guys, again, the idea is once you use the trig identity, right, try to factor. So I'm going to try to factor at the top, of course. So we can do partial factoring. So, I mean, like here and here, cosine of x would be a common factor, right? So let me factor out cosine of x. So I'm going to do partial factoring. I'm going to factor out the cosine of x. So my f prime of x. So my f prime of x is limit h going to 0. My common factor is cosine of x. So here's my cosine of x, right? Here cosine of x, and here's my cosine of x. So if you factor out this cosine of x, so then you are left with this cosine of h. So cosine of x times cosine of h. And then there's this minus. So minus, if you pull out this cosine of x, then you are left with 1 there, right? It's minus 1. Right. So that's the first, that's my partial factoring. And then there is, of course, there is this minus sine of x, sine of h left, right? So we have minus sine of x, sine of h, right? And the whole thing divided by h, but I'm going to split. So here's over h here, over h here, right? I split my fraction into 2 fractions, right? Both divided by h, of course. Now, so now I'm going to use my limits, right? So for example, here I have sine of h over h going to 0. That's equal to 1, right? Sine of h over h. It's like sine of x over x, right? X going to 0, right? That's equal to 1. So this thing here is equal to 1. And also we have this cosine of h minus 1 over h. We proved that that's actually equal the limit of x or h, x going to 0, of cosine of x minus 1 over x is 0, right? Of course, instead of x, I can use h if I want. So here's my h, right? So this cosine of h minus 1 over h, limit when h goes to 0, this is actually 0. This thing here is 0. Right? So what will be now f prime of x, right? So now f prime of x is going to be f prime of x. That will be limit. Well, it's h going to 0, right? So we have this cosine of x, right? So it's cosine of x, right? Actually, I don't need the limit, so it's just so cosine of x, right? This cosine of x here, and then times the red box here. This red box, we said it's 0, right? Because of our limit, right? We said cosine of h minus 1 over h going to 0 is actually 0. So it's times 0. And then there's minus here. So here's minus. There is this sine of x. So here's my sine of x. And then there is a sine of h over h. This limit here, we said it's equal to 1. So here it's times 1. Right? So you see f prime of x. So f prime of x is equal to minus sine of x. Right. So the conclusion, guys, derivative of cosine is minus sine. So conclusion, right? So we said f of x equal to sine of x, then f prime is cosine. And if f of x is cosine, then the derivative of cosine is actually minus sine. Then f prime of x is minus sine. Okay? So that's what we proved actually. So we proved these two formulas here, these two derivatives, right? Derivative of sine is cosine, derivative of cosine is minus sine. Anyway, is there any question, guys? Again, you can just forget about the proofs, right? It's just, I mean, it's just to show you how to get the formulas, right? Why derivative of sine is cosine, or why derivative of cosine is minus sine, right? It's just, so you can't just forget about the proof, but I mean, it's always good to see the proofs, right? How it works. But in practice, of course, you're gonna just use these, these two formulas here. You don't have to prove anything, right? If you have sine, derivative of sine is cosine, and derivative of cosine is minus sine. Anyway, guys, so let's take probably a break of 5 minutes, right? And after the break, we're gonna continue with the tangent, cotangent, secant of x, and cosecant of x, right? So let's take a break of 5 minutes, right? So I would come back, let's say, at 7:41, right? Okay, so break 5 minutes, guys. All right, guys. So let me just remind you what we just learned. So first, okay. So what we just said is, well, derivative of sine of x, right? Derivative of sine of x is actually cosine of x, and derivative of cosine of x is actually minus sine, right? This is minus sine of x. All right, now what about, let's say, derivative of tangent of x? Okay, so next, so exercise. So what about f of x equal to tangent of x? Right. So let me just remind you the definition of tangent of x. That's sine over cosine, right? It's sine of x over cosine of x. So I want to compute the derivative, right? I want to compute f prime of x, right? Tangent prime of x. So so we want to compute well, tangent derivative of tangent of x, right? F prime of x. Well, so you know, guys, tan is a sine over cosine, right? So it's a fraction. This is a fraction, right? Sine over cosine is a fraction. So we can use the quotient rule, right? So we can use because this is a fraction, so we can use the quotient rule, right? Quotient rule, right? So what I'm saying, guys, is that, you know, my tangent of x, as I said, it's sine over cosine. So it's like my f, it's like, you know, it's like f of x over g of x, right? So what will be the derivative of f over g? Well, that's the quotient rule, right? So then, so the derivative of tangent of x prime, so the derivative is, so we're gonna use the quotient rule, because again, it's a fraction. So quotient rule. And what does it say, the quotient rule? It says it's f prime g minus f g prime over g squared. Right? That's our quotient rule. Now, what's f and g? So again, the f is the top, is the sine, and the g is the cosine. Right? So if I want to apply the quotient rule, I'm going to need f prime, then times g minus f times, and then I'm going to need g prime. but I mean, f is sine, f prime. So what's the derivative of sine? Well, we just said derivative of sine is cosine. Now, g is cosine, right? So what will be g prime? What's the derivative of cosine? Well, we just said it's minus sine, right? So if you apply the quotient rule, then so the derivative of tan, or tangent of x prime, so derivative of tan, so it's f prime, it's f is sine, f prime would be cosine of x times g. See, here's g here. My g is the denominator, so it's times cosine again. Then in the rule, quotient rule, this is minus, so here's my minus. F, again, f is this top here, which is sine, so minus sine of x times g prime. So what's g prime? G is cosine, and we just said derivative of cosine is minus sine. So derivative of g, which is cosine, is minus sine. So this is here, this is minus sine. So this is minus sine of x. And the whole thing divided by g squared. So g is, again, g is the bottom, right? It's the cosine. So it's cosine squared of x. Right, so let's see what we have in the top. So it's tangent of x prime. So cosine times cosine, that's cosine square of x, of the angle x, of course. Then there's a minus. See this minus here? Minus, there'll be a plus. So it's a plus here. Sine times sine, that's sine square of x, right? Over cosine square. Now, you know, so cosine square plus sine square, of course, that will be equal to 1, right? That's a trig identity, right? Cosine square plus sine square is equal to 1. So then tangent of x derivative. So we are saying sine square plus cosine square is equal to 1. So it's equal to 1 over, so 1 here over the cosine square of x. Right? So derivative of tangent prime is 1 over cosine square, right? Now, yeah, so but just to remind you guys, actually 1 over cosine it's called secant of x, right? So just remind you, secant of x is 1 over cosine of x, right? And cosecant of x is 1 over sine. Right? It's just definition, right? Definition of secant of x and cosecant of x. But anyway, the thing is, so because, you know, derivative of tan is 1 over cosine square, so that's actually, it's exactly secant square of x, right? So, so tangent prime, so tangent of x prime is, you know, it's actually, you know, if you have a secant square, so if I put square here, there's a square here, there's a square here, and of course, 1 square is just 1, right? So 1 over cosine square is just a secant square. So derivative of tan is actually just the secant square of x, of course. All right. So that's the derivative of tangent. Well, okay, so what about, so that's for tangent. What about cotangent? Okay, so exercise. So this is how we prove that the derivative of tangent is secant square, right? So please try to compute exercise. Okay, so find derivative of cotangent of x prime. So let me just remind you. So cotangent of x is actually cosine of x over sine of x. All right. Yeah. So please find. Please try to find derivative of cotangent of x, and also derivative of secant of x, and again, secant of x is just 1 over cosine, right? That's what I mean by secant of x, and then cosecant of x prime. Okay, so cosecant, guys, of course, that will be 1 over that will be 1 over sine of x. Okay. Anyway, so to compute the derivative, please use the quotient rule, right? Because so to compute the derivative of cotangent, secant, and cosecant of x, I mean all of them by definition. So you have like a fraction, right? So then to compute the derivative, you have to use the quotient rule. So I'm gonna give you a couple of minutes, guys, to think about derivative of cotangent, derivative of a secant, and derivative of cosecant. So again, here you have to use the quotient rule, right? Use the quotient rule. So I guess, guys, after trig functions, so we know how to compute the derivative of powers of x. So now we are doing trig functions. Next, we're gonna do, of course, logarithmic functions and exponential. Right? And so you're gonna have so many formulas, and again, you don't have to memorize all the formulas, right? Um, I mean, of course, you need to know a couple of rules, like the product rule, the quotient rule, right? But in general, I mean, in the test or in the final, you don't have to memorize all those formulas, right? Just write down. You can write down the formulas in a sheet of paper, right? And then you can use them, right? You don't have to memorize everything. So any guess for derivative of cotangent? So derivative of tangent was 1 over cosine square, right? Yes, Ibrahim, but actually it's minus cosecant square. Yes, Elias, yeah, absolutely. So it's minus 1 over sine square. Exactly, yeah, very good. It's minus 1 over sine square, which is minus cosecant square. Yes, absolutely, guys. Mm-hmm. And any guess for secant of x? What would be the derivative of secant of x? Yes, Elias. Yeah, absolutely. Yeah, very good. It's sine over cosine square. Yes, absolutely. Yes, very good. And actually, sine over cosine square, you can write it like secant of x times tangent of x, right? Because secant is 1 over cosine, and tangent is sine over cosine. So secant times tangent is exactly the sine over cosine square. Rahima, you're saying sine of x times secant square of x? Yes. Mm-hmm. Yes. I mean, in the textbook or in the in the literature or in the textbook, I mean, there are different ways actually to express the derivative of. I mean, they are all equivalent, right? Like the derivative of tangent, we said it's 1 over cosine square, of course. But if you use a secant, that would be secant square, etc., etc. Right? So it's just there are just different ways, right, to express the same thing, to express the derivative. Okay. Anyway, guys. So yeah. So probably I should go over the exercise now. So first, you want to find the derivative of cotangent, right? So we want to find, so cotangent of x, cotangent of x, we said it's cosine over sine, right? That's the definition of cotangent of x, right? Cotangent of x. Now, you want to compute the derivative, right? So we want to compute cotangent of x prime, the derivative of cotangent, right? So because this is a fraction, right? So if you want to compute the derivative of a fraction, you have to use the quotient rule. So we have to use the quotient rule, right? So this is like f over g. So this is like f of x over g of x, right? My f is cosine and my g is sine, right? And I want to compute the derivative of f over g. So of course, then we have to use the quotient rule. So here I need the quotient rule. It's f over g, so quotient rule. The quotient rule says the derivative would be f prime times g minus f g prime over g squared. Right? Again, guys, f is the top, it's cosine, and g is the denominator, is the sine. Okay. So now I'm going to use my quotient rule, which is f prime times g minus fg prime over g squared. So let's see. So this derivative, cotangent of x prime. So first I have f prime. So what's f prime? F is cosine. F prime, we just said, where is it? Here. So derivative of cosine is minus sine, right? So derivative of cosine is minus sine. So then f prime would be minus cosine. Minus sine. So f is cosine. So it's minus sine. That's my f prime. Right? This is f prime, right? Times g. G is sine of x. So times sine of x. And then, of course, there's a minus. It's minus here. So here's minus f. F is cosine. So cosine of x times g prime. So what's g prime? G is sine. So derivative of sine, we said it's actually cosine. So here it's times. So it's times cosine of x. This is times cosine of x, right? That's my g prime over g squared. So here over g is sine, right? So over sine square of x, right? So cotangent of x prime. So it's there's this minus sine times sine. It's sine square. There's this minus here, so it's minus cosine times cosine. It's cosine square over sine square. Over sine square of x. All right, so is this minus here? There's a minus here. Right now, minus sine square minus cosine square, guys. I mean, sine square plus cosine square. You know, sine square plus cosine square. Sine square plus cosine square is 1. Right? So if you multiply everything by -1, so here minus by -1, -1, -1. So minus sine square minus cosine square, that will be -1. Right? So here, this derivative of cotangent of x prime, so it's going to be actually a -1 in the top. So here again, I'm using trig identity, right? I'm using sine square plus cosine square is equal to +1. Then minus sine square minus cosine will be -1 over sine square. All right. So what we are saying is that cotangent of x derivative is minus or -1 over sine square. But then, guys, so just to remind you, I mean, we said the definition of cosecant of x is 1 over sine, right? Cosecant of x is 1 over sine, right? So if you put square, here, that will be square, 1 square, it's 1, and the sine square, right? So derivative of cotangent, so this thing here, this actually, it's equal to, so this is minus, and 1 over sine square, it's just cosecant square. So it's minus cosecant square of x. Right. So here's minus 1 over sine square, 1 over sine square. Here we said it's cosecant square. Right. So anyway, yeah. So the derivative of cotangent, it's actually -1 over sine square. In other words, it's negative cosecant square. Right. What else? Well, we can do also derivative of secant of x. So number 2. Is there any question, guys? So all we are doing here is using the quotient rule and using the fact that derivative of sine is cosine, derivative of cosine is minus sine, right? To compute the derivative of tan, cotangent, secant, and cosecant, right? So now, we're gonna compute derivative of secant of x, right? Secant of x, by definition, right? Secant of x is supposed to be 1 over cosine, right? That's the definition of secant of x. And I want to compute derivative, secant of x prime, right? Derivative. So what would be the derivative? Well, secant of x is 1 over cosine. So this is a fraction, right? It's f over g. So it's f of x over g of x. My f is 1, and my g is the cosine. So if you have a fraction, if you have f over g, and you want to compute the derivative, then you have to use, it's a division, right? So you have to use the quotient rule. So here, I have to use the quotient. It's a derivative. It's a division. So it's a fraction, and I want to compute the derivative. So I'm going to use the quotient rule, and quotient rule says that the derivative would be f prime g minus f g prime over g squared. Right? Okay, so let's see. So then derivative of secant of x. So what's f prime? F is 1, right? F is a constant, just 1 by itself, a constant by itself. So if you have a constant by itself, the derivative, we said it's 0. So f prime is 0 times g. G is, of course, is this cosine. So 0 times cosine. Then there's minus here. There's a minus. Then f. What's f? F is 1. So minus 1 times g prime. So what's the derivative of g? G is cosine. And we proved that actually derivative of cosine is minus sine, right? So derivative of cosine is minus sine. Right? And then, of course, the whole thing divided by g squared, right? This g squared here. So my g again is this cosine, right? So then cosine square. G squared would be cosine squared. Any question, guys, about this? So yeah, so then we can simplify the top, of course. Secant. So derivative of secant of x, derivative. So 0 times cosine. This here thing is 0. And then we're gonna have minus, that will be a plus. So it's plus 1 times sine. So it's sine of x. So this is sine of x in the top over cosine square. Right. Right. So that's the answer. And actually, there's another way, of course, to express this this derivative. Another way would be to say, in other words, you can write this, derivative of secant of x prime, which is sine over cosine squared. I can write it like, sine. So I can write it like sine over cosine times cosine, right? Cosine squared, it's cosine times cosine. And here, I'm going to put times 1 here, all right? So that will be sine over cosine. By definition, it's tangent, right? That's the definition of tangent. So derivative of secant of x, it's actually, so this is tangent times, and 1 over cosine, right? 1 over cosine, it's secant of x. 1 over cosine is secant of x. That's the definition of secant of x, right? So that's another way to express the derivative of the secant of x. So derivative of a secant of x is actually tangent times secant of x. All right, but again, guys, I mean, it's up to you. You can use this formula here, sine over cosine, or this one here, tangent times the secant of x. It's up to you, right? Any question, guys? Okay, so the no question now for cosecant in the same way, right? And so you're gonna have actually minus, we're gonna have minus cosine over sine square. So just a summary here, we summarize all the formulas we have. So derivatives of trig functions. So derivatives. So what you need to know is the following. So derivatives of trig functions. So the formulas that you need to know are the following. So first, you need to know that derivative of sine of x is cosine of x. All right. You need to know that derivative of cosine of x is actually minus sine of x. Okay. Derivative of tangent of x, right? We proved that it's actually equal to the secant square of x. So again, secant of x is 1 over, it's 1 over cosine, right? So derivative of tangent, it's actually secant square of x. Or in other words, it's 1 over cosine square. And then we just proved, so we just proved that derivative of cotangent of x. So we just proved that this is actually equal to minus cosecant square of x, right? That's what we just proved here, right? The cotangent, cotangent derivative, we said it's minus or negative 1 over sine square, which is minus cosecant square, right? That's what we proved. Next, we proved the derivative of secant of x. Secant of x, again, secant of x is this 1 over cosine, right? It's 1 over cosine. So derivative is, we said it's secant of x times tangent of x, right? And the last formula, guys, is similar to the derivative of secant, the derivative of cosecant. So cosecant of x, so cosecant of x is, of course, it's 1 over sine. So cosecant of x is actually 1 over sine. All right, 1 over sine of x, of course. So that's a derivative is actually minus cosecant of x times cotangent of x, right? Anyway, so we have now all these formulas. Again, you don't need to prove again all of these formulas, right? So now we're gonna use them, right? We're gonna just use all these formulas to compute the derivatives, right? So here's an exercise. So for example, let's say you want to compute, so how to apply all these formulas. So for example, let's say an example, right? So let's say we have f of x equal to x times cosine of x, for example, right? And I want to find f prime of x. Right? Well, let's say here x squared instead of x, let's say it's x squared. Okay. Anyway, so So when you have to compute the derivative, guys, you need to know which formula you have to use, right? So you need to know whether you have addition, whether you have subtraction, or you have a product, or you have division, right? So for example here, this is x squared times cosine, right? This is a product, right? So here we have a product, so we have to use the product rule, right? So this is a product, it's multiplication, right? It's a product. So we have to use product rule. Right? And now, because, well, we know what's the derivative of cosine now, right? So so I'm going to use the product rule. So what's the product rule? So it's, you know, if you have like, let's call this function here, instead of f, I'm going to call it h. So here, this is, let's say, h prime. All right, so now what's the product rule? Well, let me just remind you. So here's, let's say, f times g. So the derivative, so h prime, so this is a product rule because, so again, we have multiplication, so we use product rule. So the product rule says that that's f prime times g plus f times g prime. And now, so I'm going to compute my h prime. So my h prime, first, f prime. Well, f is x squared, right? So what's the derivative of x squared? It's a power of x, right? So remember, when we have a power of x, what we do is we bring down the power in front of x and we subtract 1 from the power, right? So then the derivative of x squared, that will be 2x. So it's 2, bring down the 2 and subtract 1 from the power. 2 minus 1, it's 1. Now, times g, right? My g is, so what's g? Well, the g is this cosine, right? The f is x squared and the g is the cosine. So times g, so times cosine of x plus, and then we have f. F is the x squared times the g prime. So g is cosine. What's the derivative of cosine? Well, we have now the formula. So we know that the derivative of cosine is minus sine. All right, so it's now x squared times g prime, derivative of cosine, so it's minus sine. Right. So then, so find answer. So find answer h prime of x, that's 2x cosine of x. There's this minus here, minus plus, that would be minus, right? There's this minus here, x squared sine of x, right? So you see, guys, how we use this, the formula we just learned, right? Derivative of cosine, it's a minus sign. So now we're going to have functions with powers of x and also trig functions, right? Okay, is there any question, guys, about this example? All right. Okay, so good. Then here's an exercise. I'm going to give you a couple of functions, and you need to compute the derivative, right? Exercise. Okay, so please find h prime of x, right? So first function, so h of x is equal to tangent of x minus 1 over secant of x. Okay. Number 2, h of x is equal to cosine of x over x. Right? Number 3, so h of x is equal to, well, it's x squared, or sorry, x cubed times sine of x. All right, guys. So I'm gonna give you, let's say, 5-10 minutes to compute the derivative of the functions h, right? Of course, you need to simplify your answer, right? So please try to simplify your answer, if it's possible, of course. Of course, for number 1 and number 2, guys, so we have division, right? We have fractions, so we have to use a quotient rule for number 1 and 2, right? For number 3, it's a multiplication, it's a product, so we use the product rule. So guys, I mean, if this is your first time doing the computing derivatives, so then, yeah, of course, tomorrow in the homework number 6, you're gonna have a lot of derivatives to compute, right? Powers of x, trig functions, product rule, quotient rule. So you have to practice. You don't have to memorize the rules. You can just, you don't have to memorize all the rules, but you need to know how to apply the rules, right? But yeah, in the homework number 6, there's gonna be a lot of derivatives to compute. So I would suggest, my advice is try to practice a lot all these derivatives, all these rules, right? Because now we start to have a lot of rules, and yes. So so if you do the homework tomorrow, homework number 6, then you're gonna have a lot of derivatives to compute. So it's a good opportunity actually to to apply all these rules, right? Brahima, actually, for number one, guys. So as I said, you have to simplify your answer. So for number one, your final answer should be actually sine of x plus cosine of x. So please, if you don't get, try to simplify your answer. So for the answer for number one, h prime of x should be sine of x plus cosine of x. So if you get something else, so please try to simplify your answer. All right. So here should be find h prime and simplify if possible. Simplify your answer when it's possible. guys, I guess, I mean, we have like 7 minutes left. So what I'm gonna do, I'm gonna probably solve number 1, okay? And next time, I guess, we can do number 2 and 3, all right? So for number 1, so it's of course it's so it's h of x, which is tangent of x minus 1 over secant of x, right? And as I said, when you want to compute the derivative, first you have to ask yourself, so which operation do we have here? So here, for example, this is a fraction, so we have division, right? So this is, this is f of x over g of x, right? So it's a fraction, so we're going to use the quotient rule. So h prime of x should be, so quotient rule. So this should be, the quotient rule should be f prime times g minus f times g prime over g squared, right? So let's see, h prime of x, then it's f prime. So what's f prime? F is tangent of x minus 1. So first I have tangent of x. So what's the derivative of tangent of x? Well, we said derivative of tangent of x is actually secant square of x, right? So we have secant square of x, and then there's minus 1. 1 is just a constant by itself. So derivative of constant by itself is just 0. So it's secant square of x minus 0. All right. Then times g. So times the secant square. G is the secant of x. So times secant of x. And then here it's a minus. Here's a minus. F is the tangent of x minus 1 times g prime. So what's g prime? Well, g is secant of x, right? So what's the derivative of secant of x? Well, if you check our formulas, right? Derivative of secant of x is secant times tangent, right? So this is secant of x times tangent of x. So this is times tangent of x. And of course, the whole thing divided by g squared, right? And g is a secant of x, so it's secant square. Right? So it's, so my h prime of x, so my h prime of x, so we have secant squared times secant, that's secant cube of x. So I'm gonna split this fraction here, right? So we have secant cube over secant square, right? Here in the denominator I have secant square. Here there's a minus, so minus, and then we have tangent of x minus 1, secant of x, times tangent of x, divided, of course, by so divided by secant square of x, right? Secant square of x. All right. So now, so let's see. So then h prime of x is equal to, well, so here, guys, in the top, so you see here, this is secant cube over secant square, right? This is secant cube over secant square. So it's just, this is just a secant of x, right? This is secant of x, right? And here minus, And then we have the tangent of x minus 1 times a tangent of x. And then you see here, this is a second over second square. So now it's going to be over, so tangent of x minus 1 times tangent of x over secant of x. All right. So that'll be equal to, so again, we can try to simplify to see if this is equal to sine of x plus cosine of x, right? Let's see. Well, so h prime of x, so it's going to be secant of x, right? We want to prove that this is actually sine of x plus cosine of x, right? So I'm gonna write everything in terms of sine and cosine, right? So here, this secant of x, it's just, by definition, it's 1 over cosine, right? This is 1 over cosine minus, and then tangent of x. Tangent of x is sine of x over cosine minus 1 times sine of x over cosine, the whole thing over secant of x. So secant of x is, of course, 1 over cosine. 1 over cosine of x. Right? So then h prime of x. So I'm just using definition of secant. Secant, we said it's 1 over cosine, and tangent, it's sine over cosine, right? So then h prime of x is going to be 1 over cosine of x. And here, so you see here, guys, I can divide. So I divide by 1 over cosine. So when you divide by 1 over cosine, you have to flip the fraction in the denominator, right? When you divide by a fraction, you'll flip the fraction, right? So it's actually minus, well, we have this, sine x, cosine x, minus 1. So I'm going to probably erase this here. So times sine over cosine, and then I'm going to flip the 1 over cosine. So it's times cosine of x times over 1, right? So you flip the denominator, right? Now, let's see. So we multiply by cosine of x. So we're going to have, so we multiply by cosine of x. So we're going to have, so here, this is cosine here over cosine. So it cancels out, right? So it's going to be equal to, so then h prime of x, it's 1 over cosine minus, and here we have this sign here. So I'm going to multiply, right? Sine here and sine here. So minus sine square of x over cosine minus sine of x, right? So you can see, guys, so this is, so it's equal to, I'm sorry, I am going over time. I'm gonna just, I'm gonna be done in 1 minute, okay? So this is minus sine of x. Anyway, so let's see here. You see there is a plus sign. So we are almost done. So this is h prime of x equal to 1 over cosine of x minus sine square of x over cosine of x minus, that will be a plus sine of x, right? So just the last thing here, this, you see here, 1 over cosine minus sine square over cosine, that's a trig identity, right? I mean, h prime of x is gonna be, we have a common denominator here, right? So it's 1 minus sine square over cosine of x, right? It's a common denominator. So it's 1 minus sine square over cosine, and then we have this plus sign. Right now, 1 minus sine square, it's trig identity, it's a cosine square, right? So this h prime of x, it's actually cosine square. This is trig identity, right? 1 minus sine square is cosine square. All right, so it's cosine square over cosine of x plus sine of x. And finally, cosine square over cosine, that would be just cosine, right? Cosine of x, so we have, so then h prime of x, it's cosine of x plus sine of x. Anyway, yeah, so you see, guys, how we simplify this trig. I know it's a lot, but yeah. So that's why, so if you simplify your h prime, then you are supposed to get cosine of x plus sine of x. Sorry, guys, I went over time, so I'm gonna stop here. So I guess I will see you on next Monday. Again, I will post homework number 6 tomorrow, right? And yeah, so that's it, I guess. Well, so good night, everyone. Thank you, everyone. I'll see you next time.
Thank you, Professor.
Thank you, Whitney.
Okay.
Thank you, Whitney. See you.
Professor,
Take care. Yes.
can you just wait like 1 minute before you you log out? Like 1 minute, I'm gonna finish up copying it.
Oh yeah. Take your time. No problem. Sure. Yeah. I actually I'm gonna download the notes, of course. But I don't know. Sometimes when I download the notes, sometimes it's the notes are kind of not clear. They're kind of blurry. But I guess because I have to use like a lot of pages. Because if I just write everything in one page, then it becomes blurry for some reason. I don't know if there's a way to fix that. But anyway, yeah. This is not clear.